we're going to look at solving these problems using kinematics. Now, we can just use one simple kinematic formula. And if we look at our first question, where Brian threw a spear 201.24 meters. Now, he threw it at a degrees of 35. So 35 degree angle, throwing it at 201.24 meters. What is that initial speed of our spear? So first, I'm going to start by writing down my givens. And with my givens, 201.24 meters. And then I'm going to draw a picture. So let's say my picture (35 degrees). It's my angle. Here's my picture. And we know that that distance is 201.24 meters. Now you might not think, that might not be a lot of givens. We can also say our A and our Y direction is negative 9.81 meters per second squared. But other than that, we don't really know much. So what do we need to do? We need to actually use two equations. So we're going to start off in the horizontal direction. The way I'm going to do that is I'm going to move up. We have our given still. So I'm going to start in the horizontal direction. Now I'm going to have change in x equals my VI x t plus 1/2 a t squared. Now my acceleration in the x direction is just 0. So this whole entire thing goes away, leaving us with our change in x equaling VIX times t. I'm just going to solve this for t so we can use it later. And you would figure that out later, that you need to solve for t if you didn't know. Equals that. Now we still don't have this, and we're going to come back to that. But now I'm going to look in my vertical direction. And I'm going to put v, change in y, so the change in y equals vi in the y direction t plus 1/2 ay t squared. So now, looking at that, we still don't have that. We have this. It's not 0. I'm going to leave it like that. So I'm going to come up to the top. We can see that in our x direction, this would be our VIX. Our y direction be upward. This would be our VIY, which gives us a resultant vector of V. I'm just going to call it VR, so I can keep a subset on it, but you can just put V either way. So we use trig to figure out what these are. And with trig, we know that sine of theta equals our opposite over hypotenuse. And we know cosine of theta equals adjacent over hypotenuse. So we can actually rearrange these both to equal that, and then cosine of theta times our hypotenuse equals that. And you might say, how is that going to help me? Well, that helps me because now I can say sine of theta times VR equals VI delta y. Or not delta y, just VIY. And I can say over here, cosine of theta, VR, equals VIX. Look at that. We can plug those right in. Now, this t right here, this t right here, this t right here, those are all equal. The nice thing about them all being equal for us, I can plug this t in here and in there. So if I plug it in, I get delta y equals, plugging this in here too, sine of theta VR times delta x over cosine theta VR plus 1/2 a t squared, so delta x over cosine theta VR squared. Now I'm going to simplify that. These go away. So I get change in y equals sine of theta over cosine theta times delta x plus ay over 2 cosine squared theta VR squared. Now if I rearrange that even more, I'm just going to move this down, I will get delta y minus sine theta x Now if I just do more algebra, I get VR squared equals ay delta x squared over 2 cosine squared theta times delta y minus sine theta over cosine theta. So that's what I get. Now, instead of rewriting it all, take the square root to get rid of this square right here. To get rid of that square, there it goes. It's gone. Okay. So that's our VR. Well, guess what? In our particular case, when we plug in all these numbers, we can see that our delta y is 0. Because we started here, we ended here, so our delta y equals 0. Now our theta, what's our theta? Well, our theta is 35 degrees. What's our x? Our x is 201.24. So that would be our x. So if I plug all of this in here, I get our VR to equal negative 9.81 meters per second squared times 201.34 meters squared over top of 2 cosine squared 35 degrees minus sine 35 degrees times our 201.34 meters divided by cosine of 35 degrees. That's going to give me my VR to equal 45.85 meters per second. Remember, velocity is direction and magnitude. So I gotta have my direction at 35 degrees north of east, because that's what I decided it was gonna be based on my picture, knowing that north is up and east is to the right. So there we go. And that's how you solve number 1. And you can actually use that too in our lab. So when we are doing our lab, you're using the same equation to find your resultant vector. For your launchers, velocity. And in our case with our launchers, our change in y will be right here, change in x right here. Our AY is always negative 9.81 meters per second. And there you go. And you can figure everything else out with that equation.